navigation problems in trigonometry. I'm just starting into an example here. A ship leaves port on a bearing of north 30 degrees east and travels for 6 kilometers. How far east or west of its starting point is it by the end of its trip? There's a set of processes that we must follow with navigation problems. You draw a compass rose and you always start with the center of the compass rose at the start of the trip. You may need to draw more compass roses if your ship or whatever's traveling changes direction, but you start with a compass rose at the start. It's always very important to read the question quite carefully. So we draw a diagram of what's happened. A ship leaves port, so our port is at the center of our compass rose, and they're on a bearing of north 30 degrees east. Try to get it sort of accurate when you draw in the trip. So we're between north and east, and 30 degrees means we're a bit closer to north than east. Put in the angle that we know, and we know that distance was 6 kilometers. Once you've drawn the trip and the bearing, you will need to work out where the triangle is. Now, when we've got these questions where they say how far east or west of the starting point did it end up, or how far north or south, that's usually a really good indication that we'll have a right-angled triangle, and there's two spaces in here that I can draw a right-angled triangle. From the end point, I can draw a triangle that goes south, and the distance east of the starting point that my ship traveled is this distance here. We're asking simply for how far east, in this case, it moved, ignoring the fact that it also went north. So that will be my x. But if you're being observant, you'll see that when I'd drawn this exactly the same way, and that was 6 in there, I could indicate that my triangle was here, and that distance x is still the same, but you'll see I don't have to do any calculations with what the angles are in my triangle. Now, when we're navigating, it's really important to look for alternate angles, and remember that all our north-south lines are parallel and all our east-west lines are parallel. So if I'd wanted to get this 30 degrees in my first diagram into the triangle, it is of course an alternate angle with this angle up here. So this one's 30 degrees. So either way, I end up with a right-angled triangle with an angle of 30 degrees. The opposite is x and the hypotenuse is 6. It's just that there's two different ways of drawing the diagram. So when we see this sort of question, how far east or west of the starting point, or how far north or south, we end up with a right-angled triangle problem. We label our triangle. I've got opposite and hypotenuse. I'm using the second one since it's slightly less untidy. That will be sine. Sine of the angle is opposite over hypotenuse. Sine of 30 degrees is, the opposite was x over the hypotenuse was 6. So x is 6 sine 30 degrees. And check that your calculator's in degrees mode. Yes, we are. 6 times sine of 30 degrees, and, well, that's neat. It's 3 kilometers east of its starting point. Now it has given me options east or west. Obviously in this question the ship went east of its starting point. It was a word question. Give it a word answer. The ship is 3 kilometers east of its starting point. So that's probably the easiest of the navigation problems, when we have one bearing only, one trip of a set distance, and we just have to work out how far east or west, north or south, we ended up away from our starting point. The next type of problems in the next video, generally non-right angled trig.